Hello maths fans, Dr Tom Crawford here at the University of Oxford, and today I'm sitting an A-level further maths exam. Now I'm expecting this to be a little trickier than the A-level maths exam that I sat in my last video, but again, I'm coming at this completely blind. I've obviously not looked at the question paper, I haven't looked at the syllabus, I'm just kind of going off memory from many years ago when I did further maths A-level. I've again got my trusty Casio GCSE, thanks for everyone pointed that out, calculator with me. I unfortunately don't have anything else, so I guess I will have to make do. I'm going to be writing on my iPad once again, so I'll share my screen so you can all see what I'm doing. And I'm going to try and explain my working again like before. So I'm not technically calling this a speed run, though I'm hoping I can do this in a lot less than the 1 hour 40 that I have to do this exam. Right, let's do this. So I've got the Pearson Edexcel 2018 Core Pure Mathematics, Further Mathematics paper. Again, I'll put a link in the description so you can have a go at this paper for yourselves. I'm actually going to pay attention this time. It says there are 9 questions and the total mark for this paper is going to be 80 and I've got 1 hour and 40 minutes. Right, my time starts now. Okay, so question 1 is asking me the inverse of a 3 by 3 matrix. And for only 2. Okay, I'm going to assume there's an easier way to do this than what I'm thinking, or maybe your calculator does this. I mean, I don't think my Casio will give me the inverse of a matrix, but I do know how to calculate the inverse of a 3 by 3, though I would definitely give more than 2 marks for it. But I guess I'll do that, as I'm not really sure what else I can do. This is a good start. First question, first part of the first question. Okay, so I've got a matrix M. So what I'm going to do is form what we call the augmented matrix, which is where you put your matrix M, 1, -2, 5, and then -3, 1, and -2, and then you put it next to the identity matrix. And then what you do is you apply elementary row operations to reduce the left-hand matrix into the identity, and you apply all the same things to the right-hand matrix, and that's your inverse, basically. That's how I would teach this to my first years in linear algebra. Oh, this is going to take forever. 0, 0, and for 2 marks. This really is there's got to be a better way to do this, but I've gone down this rabbit hole. This is ridiculous. And finally, it's ridiculous. Finally, 0 plus 5/8, that's going to be 5 over 69. Right, so my inverse is then just this thing on the right. So let me just highlight that for you. So I believe this right here is M inverse. Well, that certainly took a lot longer than expected. Not a great start. Right, solve the simultaneous equations. Okay, so those equations are actually just my matrix. So it's asking me to solve mx equals b, where we know m and b. So that just means that x is m inverse times b. So I need my matrix, which I just worked out. So let's factor out that 69 factor. And then we just had 1, 13, 5. Then it was minus 11, minus 5, and 14. Then we had minus 26, 7, and 8. So that times b, and b is just the answers there. So minus 4, 9, and 5. Okay, so this would be x. So let's just do the 1 over 69. And then we've got first row, first column. So that's minus 4. 9 lots of 13 is plus 117 plus 25. Then we've got 44 minus 45 plus 70. And then we've got minus 26 as minus 4. So that's going to be plus 104 plus 63 plus 5 times 8 is 40. So I make that 1 over 69 times 117 plus 25, 138. Okay, so that'll give me 2. Good. 44 minus 45 minus, so that's 69. And then 104 plus 63, 167, 207. Yes, that works, because then they're all going to simplify to give me 213. So I think the answer is, I'm glad that I've got nice numbers. This gives me confidence that my inverse might potentially be correct. So I think x is 2, y is 1, and z is 3. Okay, and then interpret the answer to part B geometrically. So that was part B. And so part C, it's saying interpret this geometrically. So we've got 3 equations of 3 different planes. So if we're solving them all simultaneously, it's the point of intersection. So that's the point of intersection of all 3 planes. Of all 3 planes. Fab! Okay, question 2. Let's hope this one's a little bit easier, or at least that I know how to do it correctly. So, and by correctly I mean with the methods you're supposed to use doing a further maths A-level exam. Right, so we've got a cubic equation with some roots. Okay, so z cubed minus 3z squared plus z plus 5 is 0. Okay, it has roots alpha, beta, gamma. And then we're interested in another cubic w with those roots. So so this has got roots alpha, beta, and gamma. So I can write it using factors. And then the second equation, we don't know what it looks like. We want it to look like w cubed plus pw squared plus qw plus r equals 0. And then we've got the roots in terms of the z roots. So minus 2 alpha plus 1, w minus 2 beta plus 1, and then w minus 2 gamma plus 1. And that's all equal to 0. We know that, so if you say that if z is alpha, then we're interested in w being 2 alpha plus 1, which you could say is 2z plus 1. So z is w minus 1 over 2. Right, so we've got a relationship between the roots, so therefore, if I plug that into the z equation, I should get a polynomial in w. So let's try that. So let's plug that into the z cubed, so that will give me 1/8 w minus 1 cubed minus 3 over 4 of w minus 1 squared plus a half of w minus 1 plus 5 equals 0. So now I just need to make it look like this form. So let's just do some expanding. So if I multiply 3 by 8 and then expand out my bracket, so it's w cubed minus 3w squared plus 3w minus 1. Then I've got minus 6 lots of w squared minus 2w plus 1. then I've got plus 4 lots of w minus 1, and then I've got plus 40, because that's been multiplied by 8. And now if I just collect terms, this will hopefully give me the answer. So w cubed minus 3 minus another 6 minus 9w squared plus 3w plus another 12, so that's 15w plus another 4 plus 19w, that's all of them. And then I've got minus 1, minus 6, minus 7, minus another 4, minus 11, plus 40, so that's plus 29 equals 0. So I think that is the equation up here. And so P is minus 9, Q is 19, R is 29, I think. Question 3. So shade an argon, yes, I like argon diagrams. Shade an argon diagram, the set of points given by this. Right, so I've got Z minus 1 plus I in brackets less than or equal to 3. So that's a circle centered at 1 plus I, radius 3. So let's draw that. So I've got a circle centered at 1I, so let's say it's about there. And it's going to have radius 3, so it's going to go down to like here, something like that. So that's a circle centered at 1 plus I, radius 3. And then the other bit I'm interested in is the argument of z minus 2. Okay, so 2 is about here. So I need the arg of z minus 2 to be between pi over 4 and 3 pi over 4. Okay, so that's 45 degrees. So that's sort of something like that. And then 3 pi over 4 is 90 degrees around, something like that. So I think the region is this bit here. Okay, this is more like my comfort zone. That's a solid 5, and I got 2 for that matrix. I'm not happy with that matrix question. All right, now part B. I think that's right. So that's going to be, that's part A. And now part B. Right, so W satisfies something else. Find in its simplest form is that value W squared. Okay, so I'm told that W minus 1 minus I equals 3. So that means it's on the circle I've just drawn. And the argument of W minus 2 is pi over 4. So that means I'm literally looking for this point here on my diagram. It has to satisfy both beyond the circle and that line. Cool. And I want to know W squared. Okay. So I think my starting point here is to let W be A plus I B. But then because I know that W is argument pi over 4, so this is pi over 4, that's the line y equals x minus 2. So that's the line of y equals x minus 2. So if W has to look like that, so that means my real part, which is x, which is A. So what it actually means then is I've got to lie on that line, W is A, and then it's going to be plus I times A minus 2. So that's the argument bit. Right, so W has to have that form, and I also know that its length is 3, so that means, what does that mean? So if I square that out, that means that the modulus of A minus 1 for the real part, and then minus another one, so plus I of A minus 3, the modulus of that squared is 9. So that means A minus 1 squared plus A minus 3 squared must be 9. So then I can expand that out. So then I can expand that out and get A squared minus 2A plus 1 plus A squared minus 6A plus 9 is 9. So that's 2A squared minus 8A plus 1 is 0. So that will give me A, and once I work out A, probably using the quadratic formula, then I will know W, and then I can work out W squared. Again, Not sure this is the best way, but it should give me the answer. So I've got 2a squared minus 8a plus 1. So 2a squared minus 8a plus 1 is 0, and I know that w is a plus I, a minus 2. Right, so a is minus b, 8 plus or minus, the whole thing is over 4, square root of b squared, 64, minus 4ac minus 8. So a is 2 plus or minus a quarter of root 56. I could get 4 out of that, so that would be 2 plus or minus root 14 over 2. Right. Now, given the location of A was outside my circle, so I know it's got to be the plus. So I can say now that W is 2 plus root 14 over 2 plus root 14 over 2i. So therefore, the modulus of W all squared is the real part squared plus the imaginary part squared, which is just 14 divided by 4. So if I expand that out, it's going to be 4 plus 2 times 2, so plus 2 root 14, and then plus the thing squared, 14 over 4, plus another 14 over 4. Okay, so that's 28 over 4, that's 7, so that's 11 plus 2 root 14 is the modulus W squared. Okay, let's try question 4. Part of the means water system for a housing estate consists of water pipes beneath the ground, right, straight line segments, we need a road. Okay, so the road surface has equation of a plane, right, so we've got equation of a plane, 3x minus 5y minus 18z is 7, right? And then my water pipe goes between 2 points, so it goes through the point A, I'm going to write it as a vector, minus 1, minus 1, minus 3, and another point B, which is 1, 2, minus 3. Okay, so I can see there they've got the same z coordinate, so they are therefore in the xy plane, but just lifted up at z, or down even, at z equals minus 3. So that's helpful. Right, using one to calculate the acute angle between W and the road surface. Okay, so this is part A. So the direction of W is between the two vectors. Let's do B minus A. So the direction of W is given by 1 minus minus 1. That's 2. 2 minus minus 1 is 3, and then 0. Okay, so my water pipe has this particular direction, right? And I want to know the angle between that and the surface. Well, I know the normal to the plane from the plane equation, so that's 3 minus 5 and minus 18. So if I kind of do some kind of sketching, so I've got like a plane doing something, and then I've got like a straight line, so the angle between them. So I need to know the normal of the plane down to my line. That's how you calculate angles between these things. I remember that. We do this in geometry, first year anyway. So what I need to do is the dot product between the normal vector and the direction W, I think. So I need to do 2, 3, 0, dotted with 3 minus 5 minus 18. So that equals, let's call the direction of W, let's pull that W like that. So I know the dot product between two vectors is equal to the length of each of the vectors times cos of the angle between them. Perfect. And I can also say that the dot product itself is also equal to, so I can do that, 6 minus 15, which is minus 9. And then I know the length of W and the length of N, so I know that minus 9 must equal 4 plus 9 must equal 13. Square rooted for the length, and then the length of n is 9 plus 25 is 34 plus 18 squared. All right, time to shine, Casio. Okay, so hopefully I can manage this one. So I need to do 18 squared because I'm being lazy, which is 324, and then plus 34. So that's 358. So, and then that's got a cos of theta. So I'm going to say that cos of theta, the angle between them, is minus 9 over 358 times 13 over the square root of 4654. So if I take arc cos of that, I'll get the angle. Do I need to do that? Probably. Okay, so square root of answer is 68.22, and then do minus 9 divided by answer equals 68.08, and then do arc cos, shift, arc cos, I'm getting better at this calculator. Arc cos of answer is, oh, it says math error. I did arc cos of an answer. Okay, that's not good. Let's try again. Okay, so I need to do arc cos, okay, cos minus 1 of minus 9 divided by the square root of 4654. And then I need to close my bracket. Should work. There we go. Right, 97.58. So that tells me that theta is 97.58 degrees between the plane and the line. Okay. And then part B. So now it says, using the model, find 0 centimeter, the shortest length of pipe from C, which is a point on the road. Okay, so point in the plane, minus 1, minus 2, and 0. And then, all right, so we have some so we've got a plane again, we've got some point, and then we've got a pipe. So the shortest distance is when they're perpendicular. Okay, lots of perpendicular when it comes to geometry. So we want them to be perpendicular. Right, so I know that the line W has its direction vector, which was, so some multiple of that, let's call it lambda, times 230, plus a point on W. So I can take any of those starting points. Let's take B, plus 1, 2, minus 3. Okay, so that represents W. And then, so let's just neaten that up. So I can say that's given by 1 plus 2 lambda. Then we've got 2 plus 3 lambda, and then minus 3. So any point on the line W has to have that form. Okay, and I want to know this specific point where they're perpendicular. So I want to know the line that passes through this point on the line and C. So that direction, so the direction between W to C is 1 plus 2 lambda, 2 plus 3 lambda, minus 3, minus the point C. Okay, so that gives me a plus 1, so that's 2 plus 2 lambda, plus another 2, 4 plus 3 lambda, and then that's minus 3. So I now know the direction from the line to the point. And what do I know? I need this to be perpendicular to W. Yes, because I've got 2 points. This is my general point on W, but I don't yet know lambda. But if I can make this line from C to W be perpendicular to W, then it'll be exactly the point that I want, and then I can get the distance. So I can just say that so we need perpendicular for the shortest distance. So that means I need 2 plus 2 lambda over 4 plus 3 lambda minus 3. I need that dotted with the direction of W, which we had as 2, 3, 0. That needs to be 0. So that tells me that 4 plus 4 lambda plus 12 plus 9 lambda must be 0. So that's 13 lambda is minus 16, so lambda is minus 16 over 13. Right. So now that I know the value of lambda, I can plug this into here, because this was exactly the difference between the two coordinates, w to c, and then the distance, of course, is the squared entries using Pythagoras. So I think what we can do is just say the distance is, well, let's put the values in. So the min sort of vector, as it were, is going to be 2 minus 16. Okay. 2 minus 32 over 13. Then we've got 4 minus 48 over 13 minus 3. So that's going to be 26. That's minus 6 over 13. 4 lots of 52. 4 over 13 minus 3. And so the distance, here are those entries squared. So the distance is the square root of, that's just going to be 36 over 169 plus 16 over 169, and then plus total of 9. So let's do that as 9 times 169. 1690 minus 169. 1690 is 1521. So that's 1521 over 169. Right, I am going to use my calculator. Keep forgetting I can use a calculator. So 36 plus 16 plus 1521. Do you think is right? It's 1573 divided by 169. So I think the answer is root 1573 over 169. I don't know if that's going to simplify or not. Ooh, calculator gave me the answer. So it says it's 121 over 13, so I'm going with that. So it's the square root of 121 over 13. All right, question 5. Ooh, matrices. Again, my favourite. Better not ask me to calculate an inverse. Oh no, I'm gonna like this one, I think. All right, describe the geometric transformation. Okay, right, thought I recognised this. So, rotations and reflections, love it. Again, first year geometry, I teach to my uni students. So we've got this matrix, minus root 3 over 2, root 3 over 2, and then minus a half. And it says, describe fully the single geometrical transformation represented by this matrix. Right, so I think it's a rotation matrix, but let's just check. So I know that a rotation matrix has the form cos theta minus sine theta, cos theta. So what that's saying here then is I want cos theta to be minus a half, and I want sine theta to be root 3 over 2. Right, so let's draw the graphs. So cos is going to look like that. So minus a half, that's sort of down here. That's at 90. 120? Okay, I think that's at 120 degrees. And let's just check. I think that should work for sine. So sine of 120 makes it root 3 over 2, because that's at 90. Yes, so it's yeah, that's right. Yeah, that's right. Good. 120 degrees. Yeah. Okay, so theta here is 120 degrees. So describe fully the single geometrical transformation. So it's a rotation, rotation about origin, rotation of 120 degrees from the positive x-axis about origin. Nice. Like that question. That was a good matrix question. Okay, transformation V, 2 by 2 matrix B is a reflection. I had a feeling we'd be doing reflections. So the reflection matrix, it's very similar to the rotation matrix, except you have cos of 2 theta, sine of 2 theta, sine of 2 theta and minus cos 2 theta. And here, the theta represents the angle of your line of reflection, again with the positive x-axis. So if I want a reflection in y equals minus x, so if y is minus x, that's this line here. So my angle theta there is a bit past, so that's 3 pi over 4. So theta is 3 pi over 4 there. Okay, so 2 theta is 3 pi over 2, so I need to know what is cos of 3 pi over 2, which is cos of 270. So cos of 270 is 0. Brilliant. So that's 0. And then sine of 3 pi over 2, I believe, should be minus 1. So my matrix, plugging those in, my reflection matrix, what we're calling this B, is simply 0, 1, sorry, minus 1, minus 1, 0. So that's B. Okay, given that U followed by V is a transformation T represented by another matrix, find that. Right, so matrix C for part C will just be, so we're doing U followed by V. So I want to do BA in the correct order. So that's the matrix B, which we just worked out was 0, minus 1, minus 1, 0, times my matrix A from the first part, minus a half, minus root 3 over 2, root 3 over 2, minus a half again. So let's do that expansion. So that will be minus root 3 over 2. And that's plus a half. Minus gives me another plus a half. And then that one times that one is then root 3 over 2. So I believe that is my matrix C. And then finally part D, show there is a real number K. Right, so T here is the matrix we just calculated. So I want to find a real number K for which the point 1K is invariant under T. So that means I can, if I did my matrix, which represents my transformation T, if I multiply that by 1K, if the point is invariant, I should get back 1K. So let's expand that out, see if it makes sense. Right, so I need minus root 3 over 2 plus K over 2 needs to be 1. So multiply by 2, so that tells me that K must be 2 plus root 3. So that's what the first equation tells me. And then let's see if it works for the second one. So the second equation, if this is going to be true, says that a half plus root 3 over 2K should give me K. So let's check. Let's sub in to the left-hand side for my value here. So that's a half plus root 3 over 2 times 2 plus root 3. I think this is going to work. Is a half plus root 3 plus root 3 plus 3 over 2, which is 2 plus root 3. But that's what I said K was, which does equal K, which is the right-hand side. So when K is 2 plus root 3, we have an invariant point. Fabulous. Question 6. Ooh, series. Love these. So standard results for the show this. Okay. I like how it says standard results. I guess you guys probably know this. Probably in the formula booklet, isn't it? I think I know these though, actually, off the top of my head. Let's see. So part A. So I think the sum from r equals 1 to n of r is a half n times n plus 1. That's the Gauss formula. I know that one. I think I can remember the other. So the sum from 1 to n of r squared. So it's a sixth. I want to say there's an n plus 1, 2n plus 1. Yes, that's it. That's it. Right, so I know those, and I've got to work out 3r minus 2 squared, so I'm going to have to expand that out. So if I want to know 3r minus 2 squared from 1 to n, okay, so that's the sum 1 to n of 9r squared minus 12r plus 4. So that's using my formulas, that's going to be 9 over 6 of n plus 1 to n plus 1 minus 12 times that one, so that's minus 6 and n plus 1, and then 4 summed n times is 4n. Right, so let's simplify that. What am I trying to get it to? So I want to factor out an n over 2. Okay, so I've got an n over 2, and then I've got a factor of brackets 3 times those two out. So that's a 2n squared plus an n plus another n plus 3n plus 1. Then I factored out the n over 2, so that will now give me a minus. So the n's come out, I'm bringing out some minus 12, I think. And the n's come out, so then you're left with minus 12. And minus 12, and then n over 2 is then plus 8. Okay, I think that's right. Well, I'll check now if I get the right answer. So I think I've got n over 2. Right, 6n squared. Good. And then it should have minus 3n, so I've got 9n minus 12n. Yes, minus 3n. Perfect. And I've got plus 3 plus 8, which is 11 minus 12 should be minus 1. Yes, this is what I wanted. Smiley face, because I know it's right. Okay, 5 marks. Okay, hence find any values of n for which... This is an equation. The sum from... Oh, it's not... The sum from r equals 5 to n. So I'm going to have to subtract some of the earlier terms from this. Plus 103 times... Oh, God. All right, there's a lot going on here. I'm going to need a new page. So let's look at this. So 6b. Right, so let's start with that first term. So I need to know the sum from r equals 5 to n, 3r minus 2 squared. So now I know the sum from 1. So what I can do is use our formula, which we got as well. So n over 2, 6n squared minus 3n minus 1. So we take our full formula and then need to subtract away the term when r is 1. That's just 1 squared, so minus 1. When r is 2, I get 6 minus 2, which is 4, so that's 16. When r is 3, I get 9, 7, 49. And then when r is 4, 12 minus 10, 100. Okay. So I've just used the formula we had and subtracted off those first 4 terms. Right. I probably should simplify that, shouldn't I? So that's n over 2, 6n squared minus 3n minus 1. Right, so that's 166 minus 166. Fabulous. And then I've got this cos thing for 103. Great choice of number. R equals 1 to 28. Very odd. R times, right, what's going on here? Cos of r. So we've got multiples. Cos of a multiple of pi over 2. These are going to be zeros, a lot of them. Okay, I see where they're going with this. So we want to consider that, and then we'll worry about the right-hand side in a moment. Okay, so let's just think about the first few terms. So I've got 103. So when r is 1, I've got cos of pi by 2. Cos of pi by 2 is 0. Okay. Then when r is 2, I've got cos of pi, which is minus 1. So it's minus 2 because of the r at the beginning. Then when it's 3, it's going to go back through a 0. And it goes to a plus when r is 4. Plus 4. Then you're going to get 0. Then you're going to get minus 6, 0, plus 8. Right, and that pattern's going to continue. And then the last term, think about the last, so it's going in patterns of 4, because we've got 0, and then a negative, then a 0, then a positive. And we've got 28, which is a multiple of 4. So there's going to be 7 lots of this pattern. And the last lot, there'll be a 0 minus, let's think about this. So it's the first lot of the pattern, the second lot, so the 7th lot. It's going to be minus 26, I think, plus 28. Right. Okay. Oh, and there was a 0 obviously in there as well. Right. So what's happening? Minus 2 plus 4 gives me plus 2. Minus 6 plus 8. I'm getting plus 2 for every set of 4. So there are 7 sets of 4. And I'm getting plus 2 each time. 7, 14. So I think I'm getting 14. So I think... good job, I have a calculator. 103. I think that's 103 times 14. I think. We'll see when I get to the end. For that. So this is tricky. If I'm doing it right. So right, let's put all this together, shall we? Okay. So we want to calculate 3n cubed is equal to 103 times 14 from that one, and then we've got an n value, and then that's from the top, plus n over 2, 6n squared minus 3n minus 1 minus 166. Right, so let's do 103, good old Casio. Let's do 103 times 14. Right, 1442. And the n cube's going to cancel. Good, right. So the n cubes are going to cancel. So I've got 0 equals 1442 minus 3n squared over 2 minus n over 2 minus 166. Right, so let's subtract 166. 1276. Ugh. And then multiply by 2. 2552. Okay, and that's a plus. So I think you get 3n squared plus n minus 2552 is 0. Not a nice equation, but quadratic equation says that n is therefore minus b minus 1 plus or minus the square root of b squared 1 minus 4ac, so plus 12 times 255, Jesus, 552, all divided by 6. Okay, calculator, times 12 plus 1 equals, please have a square root. Yes, has a square root. Okay, the square root of that is 175. Right, so that tells me I think we're right. So this is equal to minus 1 plus or minus 175 over 6. We want n, as the questions say. I'm assuming n's going to have to be positive. N's positive, right, so we need the plus. So 175 minus that 1. 174 divided by 6. 29. Yes, we get a nice answer. Right, so n is 29. And I'm going to give myself a smiley because after all that horrible algebra, the fact that I get 29 means hopefully, fingers crossed, I did it correct. We'll see. Okay, question 7. So we've got another cubic. I like cubics. So f of z is z cubed plus z squared plus pz plus q. Okay, p and q are real. It's good to know. Has root z1, z2, z3. Given that z1 is 3. Right, so let's call them... So I know that I have these factors. Let's call my two roots alpha and beta, just so I don't get confused. Don't like subscript notation, it can be confusing. So that would be z2, z3. And then we're told to look at the argand. I see what's happening. Right, so puzzle for a second. So we've got a real root, and the other two alpha and b's, they have to be complex conjugates. So if that's alpha, let's say that's at IB, and the other one, beta, has to be down here. So we know that alpha is A plus IB, beta is the other root, is the complex conjugate of it, and that's going to help us, I think, because now the triangle, oh, that's a wiggly line. Now the triangle, very badly drawn, we know this has area 35, so I can say that 35 is a half times the base, which is 3 minus a, going along there, and then the height would be 2b. Okay, so that's one equation involving A and B. Okay, now, so I need to get another one to try and figure out one of these values. Well, let's expand from here a little bit. Okay, so expanding that, I've got z minus 3, then I've got z squared minus alpha plus beta z plus alpha beta. So then I'm going to get z cubed, right, minus alpha plus beta z squared, and then plus alpha beta z minus 3z squared, and then I'm going to get plus 3 times alpha plus beta z minus 3 alpha beta. Okay, I think I've got it now. So from the equation at the top of the page, we've got this plus z squared, and down here we've got minus that. So it's the sum of the roots. Sum of the roots, coefficient of z, it's coming back to me. Coefficient of z squared is the sum of my roots. So what do I know? So I can say that alpha plus beta plus 3 needs to be minus 1. Alpha plus beta, that cancels the I part, so that's 2a plus 3 is minus 1. So that tells me that a is, so 2a is minus 4, so a is minus 2. So here this tells me now 35 is half times 5, so the halves cancel at 5. B is 7, yes, 5b, so b is 7. Okay, fab. So a is minus 2, b is 7. Let's start a new page. So I now know that I have the roots are z equals 3, z equals minus 2 plus 7i, and z, that would be 1, 2, and z3 would be minus 2 minus 7i. So now if I just expand them, I could just plug these actually back into my equation, but I've lost it, so let's just expand them. It's not too difficult. So we know that f of z is equal to z cubed plus z squared plus pz plus q. And we also know that's z minus 3. And then my other roots are z plus 2 minus 7i, z plus 2 plus 7i. So if we expand that, that's z minus 3 times z squared plus 2z plus 7i z plus 2z plus 4 plus 14i minus 7i z minus 14i minus 49i squared plus 49. Okay, so that's z minus 3 times z squared. They should cancel good, plus 4z plus 53, I think. So finally the answer is z cubed plus 4z squared plus 53z minus 3z squared. We're getting the z squared with one coefficient. Minus 3z squared minus 12z and then minus 159. So I think the final answer is z cubed plus z squared, which is what we wanted, plus 41 z minus 159. So therefore P is 41, Q is minus 159. All right, question 8. Ooh, induction. This will be fun. Hey, bit of proof. Forgot we did this at A-level. Right, proof by induction, this matrix formula. Love it. Okay, so number 1. So we're going to consider our base case, which is when n is equal to 1. So 5 minus 8 to minus 3 to the power 1 is just equal to, I can just write that in the correct form, so 4 times 1 plus 1, that's 5. Minus 8 lots of 1, that does give me minus 8. And then that's the same as 2 times n, yes. And then minus 3, so 1, minus 4 lots of 1. Perfect. So it satisfies the base case. Now we're going to assume the inductive hypothesis, assume true up to n, and then we consider n plus 1. So I already know how these questions work, so what we're going to have to do is consider 5 minus 8 to minus 3 to the power of n plus 1, which is that to the power n. Use our formula for that, multiplied by itself again. So we can do it as that multiplied by the inductive hypothesis. So 4n plus 1 minus 8n, 2n, and 1 minus 4n. Okay, so I need to expand this out and check I get the same formula with n plus 1s in. So first row, first column is 5 lots of that, so 20n plus 5 minus 16n. Okay, first row, second column is minus 40n, and then minus 8 plus 32n. Okay, second row, second column, so that'll be 8n plus 2 minus 6n. Second row, second column, minus 16n minus 3 plus 12n. Right. So let's write it out first, and then I'll put it, I think, in the induction form. So I've got 20n minus 16, so I've got 4 lots of n plus 5. I've got minus 8n minus 8. That looks good. I've got 2n plus 2. That looks good. And I've got minus 4n minus 3. But pretty sure that I can say, well, that's just 4 lots of n plus 1 plus 1. That's what I wanted. That one over there is just minus 8 lots of n plus 1, which is what I wanted. That is just 2 lots of n plus 1, which is what I wanted. And then this last one I want as 1 minus 4 lots of n plus 1, which is 1 minus 4n minus 4 minus 3. Perfect. So true by induction. Right, so that was the first one. Second one, proof by induction for n an integer. That's the original one. Fun. Okay, so let's have a go at that. Okay, so 8 part 2. We have some function f of n given by 4 to the n plus 1 plus 5 to the 2n minus 1. Right, so base case, n equals 1. So I can say that f of 1 is equal to 4 squared 16 plus 5 to the power 1, which is 21, which is divisible by 21. Tick. Okay, base case. Assume true, inductive hypothesis. Assume true up to n. Consider n plus 1. Right, so f of n plus 1 is 4 to the power of n plus 1 plus 1 plus 5 of 2 lots of n plus 1 minus 1. So that's 4 to the n plus 1 multiplied by 4. So I'm trying to make this look like the previous step so I can use my inductive hypothesis. That's the plan. Always is with these induction questions. And then so that I can say is plus 5 to the 2n minus 1, and then I've got 5 squared left, so times 25. Okay, and I've got to show that this is divisible by 21. So let's say 4 to the n plus 1, that's from up here, is f of n minus, there we go, So that now is 4 lots of f of n, which we know is divisible by 21 by the inductive hypothesis. So that's f of n minus 5 to the 2n minus 1. And then we've got plus 25 lots of 5 to the 2n minus 1. So that's now 4 lots of f of n. 25 minus 4 lots is 21. So that's plus 21 lots of 5 to the 2n minus 1. So this is divisible by 21 by the inductive hypothesis. And this whole thing here is clearly divisible by 21 because it's multiplied by that factor. So the whole thing is, so therefore true by induction. I've probably left out a few details, but I've already been doing this for quite a while. You get the idea. Okay. Final question, question 9. Okay. This has been a slog. All right. I'm excited it's the last question. What have we got? Ooh, looks like a bottle of wine. I could do with a bottle of wine after this, or beer. Any beverage is fine. The purchase is more than perfect. A glass bottle of water. They mean wine. Figure 1 shows a sketch of a cross section. Measurements taken by the student, right? So we've got a circular bit. Okay, and then we're going to model. Ooh, there's a lot going on here. Okay, so let's write this out. So I've got question 9. So first thing we have to do. Right. Okay. So the first thing, let's just do that. Right, and then I'll worry about the question. It's going to ask me to do the volume. I can tell it's going to be a volume integral. Okay, so between 1 and 4. Okay, so we've got this is at 1, and we've got this sort of curve shape, and then that's coming down, and that's at 4. So that's the point G, that's the point F. Okay, and we know the y values, don't we? So we know the height. So the height F, that's at height 4. So F is at height 14, and G up here is 4 centimeters more, so that's 18. Right, so we know that when X is 1, Y is 18, and we know that when X is 4, Y is 14. So given this equation, we're assuming Y, part A, we're assuming Y is equal to ax squared plus b. So let's take the first one. So I can say that 18 is equal to a times x squared, so that's a plus b for the first one, and then I know that 14 has to equal 16a plus b. Right, so what do I know? I know that 14 is 16a, but then b is equal to 18 minus a plus 18 minus a. So that means that 15a is equal to minus 4. So a is minus 4 over 15, which means that b is equal to 18 plus 4, nice numbers again, plus 4 15ths. Oh God, I have to do this on my calculators again. Right, I'm getting quite used to this calculator. 18 times 15, being lazy, 270 plus 4, so 274 over 15 for B. Right, that's the first bit. Use the model to find, I knew it was coming. Use the model to find the volume of water. Oh, the bottle can contain, okay. Right, I'm gonna need a new page. So, key to this is gonna be having a good diagram. Okay, so let's think about, so we're doing a volume of revolution. So what shapes have we got? So I've got like a rectangle at the top, which is half of the width. So on the diagram, that's width 2. So that's width 1. It's height 10. Then we had this sort of circular bit here, which we've worked out to be y is ax squared plus b, so that was minus 4 over 15 x squared, and then b was 274 over 15. And then the final bit is another big rectangle again. So I've just drawn half of the cross section here because I'm thinking, well, if we rotate that around the axis, we can use volumes of revolution. At least that's my plan. And it should help us because I know the width of this is 4 and the height of this is 14. So what we've got two cylinders basically. We've got two cylinders at the top and the bottom, and then we've got this sort of fiddly bit, which I'll worry about later. So let's label them area 1, area 2, and area 3. So the volume of 1 is just going to be, it's a rectangle, so when I rotate, it's a cylinder. So the volume of a cylinder is pi times the radius squared, radius is 1, pi times the radius squared times the height, which is 10. So that's 10 pi. The volume of 3 will similarly be pi times the radius squared, which here is 4, and then you square it to 16, so pi lots of 16 times 14. Okay, calculator. It's getting near the end, I'm being lazy. 16 times 224, so that's 224 pi. For 3, 1 is 10 pi, and then 2, right, so what's going on at 2? So we're rotating around the y-axis, so I can say that the volume of 2 is just equal to pi times the integral between these two y limits. So I had those before, they were at 14 and 18. So from 14 and 8, so I'm going to have to integrate with respect from 14 to 18 dy, and it's pi times the radius squared, where the radius is given by x. So it's that, so that's x squared. And then I can sub for x in terms of y for my other equation, I think. We'll see. Okay, so, right, so I think you can then say, well, that's pi times the integral from 14 to 18 of x squared. So x squared up here, I can say what? 15y is minus 4x squared plus 274. Substituting that in will give me 274 minus 15y dy. Yes, I think that's right. Good. Okay, so now I just need to do this integral. Nasty numbers again. So far I'm saying that the volume was 234 pi from the first two cylinders, and then plus pi over 4. The integral from 14 to 18 of 274 minus 15y dy. So now if I just calculate that, it's 234 pi plus pi over 4, big curly bracket, of 274y minus 15y squared over 2, evaluated at 18 and 14, which is 234 pi plus pi over 4. Okay, 274 times 18, 4932. 4932 minus, okay, 15 times 18 squared divided by 2, 2430, 2430, and then it's minus 274 times 14, 3836, and then plus 15 times 14 squared divided by 2, 1470. Okay. I hope this is right, because these are horrible numbers again. So, exhausting. 234 pi plus pi over 4. Right, put all these numbers together. 4932 minus 2430 minus 3836 plus 1470 equals 136. Marvellous. And that looks like it will divide. I'm getting so lazy. As I progressed, I'm using my calculator more and more. Get used to this. 34, right, fabulous. So this is 268 pi, I think, is the volume of our glass bottle of water / wine / whatever we want it to be. Okay, is that what I had to do? Yes, the volume of water, 268. And let's check. 268 times pi. Does that seem reasonable? Oh, where's the pi button? Don't fail me. Oh no, I got the pi button. Times pi is... Oh, it says 268 pi, but now I know to press the SD button. Thank you, everybody. Right, SD. Yes, it worked. 842. Okay, it's about 842 centimeters cubed. Is that what we're working in? Yes. Yes. Okay, I know it's right because I can see the next bit of the question. Well, I think it's right. Okay, so I think it's 842 centimeters cubed. State a limitation of the model. Well, it said in the question that we modeled the curved bit as a parabola. So that was an assumption. So the assumed parabola shape, that was definitely part of the modeling. Should get me a mark. And then finally part D says, use this information in your answer to part B to evaluate the model, explaining your reasoning. So if it says, so our estimate, so estimated volume is greater than 750, which I think sounds about right, because you wouldn't fill it all the way to the top. They're never right full to the top when you get a bottle of anything. So so I think model is pretty good. Model is pretty good. We're not a million miles off. I think 842, 750, that's about right, I think, because you wouldn't fill it full again. Model is pretty good. Smiley face. Whew, we're done. Okay, that was much more exhausting than the first one. Further maths is definitely harder than maths, so that's good. It should be. Right, I'm going to take a little break and then I'll come back. I'll have a look and we'll see how we did. Right, the results are in. And I'm pretty pleased. I was trying to keep a serious face. I'm pretty pleased. As I mentioned, that was tough. It was definitely a lot harder than the A-level maths paper I did. This was the A-level further maths paper, more advanced. Definitely tougher, as it should have been. I felt like I wasn't able to go quite as fast. In fact, I really did have to think about what the question was asking. So I felt like the time was definitely much more time pressure than I felt in the first exam. And I've looked through the mark scheme in much more detail than I did last time. I kind of glanced over it last time. And I think there's possibly only 2 marks that if I'm being generous, let's say, because my induction proof was I went through that pretty quick. But I think there's just 2 marks that I've missed, and I did miss them, unfortunately. So question 4, both of them. So the question was asking about the water pipe and the road, and basically was a geometry question about lines and surfaces and planes, normals, all that kind of thing. So in the first part of the question, it does actually say find the acute angle between the line and the plane. But my answer, of course, was 97.58 degrees, which is not an acute angle. So I actually needed to subtract off 90, so I should have had 7.58 degrees. So I think I would have lost a mark there. Got all the method marks. I think everything I did was correct. I just didn't read the question properly. Lesson learned. And then in part B, the question says, again, I didn't read it, to the nearest centimetre, find the shortest length between this point C and our line. So I left it as the square root of 121 divided by 13, which isn't in centimetres, it's actually in metres, because if you turn that into a decimal, it's just over 3 metres. So the answer should have been 305 centimetres. So again, I think my method's correct, my answer is correct, I just haven't read the question and presented it correctly. As always, thank you everybody for watching. Please do remember to subscribe to the channel. The more viewers and subscribers I get, the more likely I am to keep putting myself through this stressful situation of taking high school maths exams with 0 preparation. And on that note, if you do have any suggestions of exams you'd like me to try, put them in the comments, get in touch with me at Tom Rocks Maths on all of the social medias, and who knows where we'll end up next.